Hello everyone, welcome back. So today I will demonstrate this RTX 7 FPGA board of video in and video out. And I'll be using our CAS platform, just do everything from the browser without any local installations. So this board is already included in our template. It is this Inventor Logic Edge RTX 7. And you can get information of the board here. It is a pretty powerful RTX 7 35 or 100T board made in India, and have pretty lot of connectors. There's light sensors and ADC and DSCs with some wireless functions and VGA out or an HDMI out as well. So today you can see here I have this OV7670 camera hooked here, and I have a VGA video out and this TFT LCD screen. So let's begin. So now the board has been turned on and is connected to the USB port of the computer. Then if you have a Chromium based browser, you can directly open this website, choose this example, and you'll be here. So we already have this constraint and Verilog source file ready. And as a test, you can connect your board. So the recommended way is to use this WASM FPGA loader, which is ported from the famous OpenFPGA loader. You can just click this connect local USB and choose this board, which shows as this digital device. You choose connect, and it will automatically select the correct cable. In this case, it's the FT2232 chip, and we click this detect FPGA. Of course, since some driver problems, we may not be able to get it run without any local modifications, but all the instructions are already shown here. So if you're on Mac OS, then it should work out of the box, and on Linux it's just removing this kernel module, and on Windows it is run this command which overrides the USB driver. So we've already summed up everything, and if you want to see more details, you can also go to our documentations, and we have this web USB drivers FTDI where you can read everything about it. So let's go back. So on Linux, the thing you need to do is to run this command to remove one kernel module, which is pretty straightforward if you have ever used the command line. And even if you don't have root access, nowadays there's quite some tricks to achieve that. So now you have a root shell, and you can just execute this rmmode command. Okay, so now we go back to this CAS website, and we can just run this detect again, and if everything works, it will already detect this FPGA. So if you have a bitstream, you can program it here, and I will just click this submit to compile the example bitstream, and everything of the compilation is done in the server, and with the OpenXT7 toolchain, the compilation speed will be pretty fast. Okay, so now it has finished, and we can just use this program bitstream to program this video demo directly into our local board through this web USB. So okay, you already see something, and we can go to the code to see like what it means. So it is a clock and switches in, and there's a video camera in, and configuration for the camera. Then it's the VGA and this SPI interface, the TFT display here. And for the switches, we can see the this switch is the reset signal, which is now not reset, and this switch is the controller of whether the video goes to this TFT or the VGA. Since now we're not using the block RAM, not using the SRAM at all, but only the block RAM inside this FPGA chip, we may not able to afford much more color space or multiple buffers. So that's a very simple way of multiplexing the signal. Yeah, so if you switch it here, then you can see this video is paused and the signal will be output here. If I switch it back, and then we can see this video here is working. Okay, and then the leftmost two switches controls the color, so you can use this to control which color is shown, or a overall colors are summed to show a monochrome image. So just turn to let it show this monochrome image, and I'll turn down the exposure to let it more visible. So here you can see this screen showing my Xilinx, and if I have some small object here, you can see it's being displayed as well. The resolution is not so well, but generally you can get what's going on. You can have something here. You can see that this is a smartphone. Okay, so that's most of the functions. And you can see that from here I've been only using this website without any local toolchain installation. The code editing is done from the browser, and the programming bitstream is also done from this web USB. And no matter you have a Linux running on wherever, or you have a Mac OS device, and this platform can do it anywhere, and well, no installations at all. So finally I'll move my camera and I'll switch this switch and the exposure back. So you can see now this video is stopped, and I'll show my view to my actual monitor that shows the HDMI display. So here it is. If I'm moving my hands here, you can see the image. If I have some small text going on, you can also see it here. And on this camera, there's a small screw. Like if I rotate it, you can see the image going from like blur to not blur. Well, it might hard to see, but like you can just tune the focus by yourself. Of course, this one don't have autofocus, so yeah. Okay, I think that's all of this video. I hope if you have a similar use case or you want to try some board pretty quick, you can enjoy our platform.